So here we are back, and we will continue with the USB hub. Last time we soldered the parts for the upstream facing port, so for the host to be able to connect to it. Just turn the camera so it's straight. And we had an issue is that sometimes so it would not appear over USB, and I didn't know why, because everything else was expected. At some point I managed to make it appear over USB. And one issue I had was that I was using these crystals, and they are 24 megahertz. This is what this requires. It only requires 24 megahertz, but it needs a 20 picofarad capacitor. And somehow it didn't go to the shopping cart. And like 2 or 3 other parts, I didn't order them. And the only thing I had on stock was 18 picofarad. And I thought, yeah, 18 picofarad is, I mean, there's just 2 picofarads difference. 2 picofarad is really not a lot. So maybe 18 picofarad works. But it turns out that this is probably not the case. And we'll check it out, because since last time, I've made this. So on this you can easily, so it has an embedded crystal driver. So you provide a crystal and it drives it to 24 megahertz. But you can also inject a 24 megahertz clock. That's possible. And for that, well, you need a signal generator which is able to generate 24 megahertz. And I didn't have one. So I have PWM generators, but not for 24 megahertz. And I remember that I have this module. This uses an AD, so analog device AD9850. And this is, I think I didn't name it DTS, something like that, but it can generate square and sine waves up to 128 megahertz. And I bought that a while ago, especially for this purpose, generating clocks. And I've never used it until today. And today I just wrote some code with a black PL microcontroller, which I had on stock. I think they're hard to buy now, but I still had some on stock. And then controlling this, and it kind of works. So let's have a look at how it looks like under the oscilloscope. And I'll connect the plugs to the oscilloscope. So we need ground, and I think so there's Z out and Q out. I think Z out is the analog wave, the sine wave, and Q out is the digital wave, so the square wave. And I think you need to inject, I've never injected, no, I did, but I don't remember exactly. I think you just need to inject a square wave actually. So let's plug it in. Let me enable the oscilloscope. Also what I've changed, I spent a bit of time more on the software. Previously, you had everything. The multimeter was shown in a browser tab because I was sending it over, so reading devices over serial. The measurement unit, so the multimeter and the power supply, reading it over serial. These are this multimeter here and this switch mode power supply, this one. So you read the data over serial, then I send it using MQTT to my MQTT broker, and on the browser using Node-RED, I was able to see the values. The problem is you always had to use a browser, it takes a lot of space, there's a lot of waste of space, and so on. So I decided to rewrite and make it an OBS overlay. And this is actually what you see on the right now. This TDM, digital multimeter. This is the multimeter output, so you don't have graphs anymore and so on, but it's fine enough. You don't have as much information, but you have the crucial information. And then PSU, power supply unit, this is, yeah, the generator, so you don't have all the nice graphs, but it is plenty enough to figure out what's happening. And the most crucial values are on there. And for that, I learned to write OBS overlays. I didn't do it at all previously, and now there is, oh, sorry for the microphone. And now I wrote just a web page which grabs the data over using JavaScript and just displays them. And this is what you see on the right. And I did a similar thing for the oscilloscope. Now I can switch on the oscilloscope. This should be on the top right. And instead of having it in the browser like I did before, it just shows the screen capture. I think it's updating once or twice a second. It's not fast, but should be good enough. So now we have this. Let me connect to this module. Terminal ready. Okay. I need to set a frequency. Let's try with 100 kilohertz. So I plug in the data using serial. No, don't show you. I'm just, it disconnected. Is the connection flaky? So it's the shitty USB hub, so it might be flaky. So let's connect. Okay. Very flaky. What's happening? Is there an issue with the USB hub? Is it drawing? Yeah, we had 4.8 volts. Should be enough. Is it a connection issue? This is not a USB-C cable, but an adapter, so might not work correctly. Let's try it this way. No, it still disconnects. I'm not sure if it's a USB cable. Let's just try another USB cable. This one is a bit short. Yeah, but you won't see it. You won't see you won't see what's happening. But let me use the cable on my desktop. That might work better. So it was this the issue? Yeah, seems to be. Now it's stable. So frequency. So now I just have a terminal for now, and I just input the frequency into the terminal. I will have a button and a display, but for now. So this is yet another project to complete this generator. For now, we'll just do it this way. 100 kilohertz, and normally we can connect both lines, digital and analog, and see what is happening. That one was, I don't know if it was digital or analog. This is the second one. This is the output. And let's diminish the time. Okay, and there we have it. This is 1000 kilohertz, another 100 kilo. This is because it's on the wrong channel. Frequency. This is the frequency which is measured on the bottom. So yellow. Q is the digital clock, so it just uses a comparator, and so you see we have a sine waveform which is 2 volts high, around 2 volts, and then we have the digital waveform which is 3.3 volt high. You can also actually, if you want to go to up to 125 megahertz, you have to use 5.5 volts. If you just go up to 100 megahertz, 3 volts is enough. So let's try 24 megahertz and see if this works. 24, 1, 2, 3, 1, 2, 3. This is 24 megahertz. Now on the oscilloscope you see nothing anymore because it is on the wrong time scale. So yeah, this is a trick with the oscilloscope. See, as I go up the time scale, then the values start to appear. And this is the maximum. And the sine wave and square wave are not that clean, but I think, yeah, they're not that clean, but I think they're clean enough for generating a clock. And you see it's 24 megahertz. So my signal generator works. This is a good thing. So let's connect the signal generator. But I need to set the signal generator. Let's connect it back to the bench, and we will have it connect Don't connect it to oscilloscope. We don't need the oscilloscope anymore, at least not for now. We know the clock generator works, and now we will connect it to these pins. I need 2 pins. Just need 2 pins, since I'll probably, and then we can test if it works. Up. So I started soldering already on, and then I thought, yeah, we could do it on the stream and see if it actually works, if this is the issue. The other issue there could be simply the USB traces. So I did some sort of impedance matching. So my impedance matching of the USB line is just use not too thick lines, have them close to each other, have them over a power plane, and that's almost it. So they're not completely length matched, but they're very close to each other all the time. And this is my impedance control. So the impedance could be wrong because I could use the wrong ratio between the track width and the track spacing for this 4-layer board, which has some characteristics on how thick the layers are. So that could be the other case, but I think that would surprise me if this would be the case, because USB 1 and USB 2 are so not too high speed, so it's quite resilient. And if this with the clock injection doesn't work, then we can still do connect USB wires from a USB cable directly on the chip and not going through all these things. That's possible. So I've soldered on X1 the input, a clock input. X2 needs to be tried to ground. We'll just leave it floating. We just don't use it. And then you have to remove the capacitor, because the capacitor might interfere with the clock, which it will actually interfere with the clock. So I remove the capacitor, and Q is the digital output. So we have ground. This is ground, and then we need Q1 or Q2. We don't really care. The other one is just a complementary output. So this way, so we have leads 24 megahertz going over such leads. It's not ideal. Let's see if it works. If it doesn't, I'll try to make the cable shorter, but just let's hope it works. So is the connection stable from this USB device? No, it is not. Damn it. Let me get another USB cable. Up. This time a proper USB-C cable. Up. Is the connection stable now? Yeah, now it is. So it's just probably this adapter, or the combination with the cable and the adapter, which is not fine. So let's switch off the oscilloscope. You don't need it anymore. And let's set 24, 1, 2, 3, 1, 2, 3 megahertz. 24 megahertz, set to 24 megahertz. And now we have to plug the USB. I can show you the outputs of, so this, yep. And now if we connect the USB device, the USB hub, we will see if it appears or not as USB hub, and if it does, then this was the issue, and I just need to use 24 picofarads. So it seems that wasn't the issue. Cables, no, one of the pins has been disconnected. The clock input actually ripped off. I didn't solder it correctly. So without clock input, it won't be able to enumerate. Let's try again. Oh, they're not. Okay, they're not as long, each one. This is kind of a pain. Let me make this correctly. Okay. Some solder. You really have to be aware with these DuPont cables. Sometimes they're made of aluminum, so it's okay if you crimp them, but you can't use them to. You can't reuse them to solder. So sometimes I just use ready-made DuPont cable. I cut them and I reuse them, like here. And on some cables, it just doesn't work because they're made of aluminum, copper, or any. A thought of copper, a thought of metal, which I can't solder on. It's either pure bad copper, really rusted, oxidized, or aluminum. I don't know exactly. I don't bother. I just remove it. I will change the code so if it gets power, it does 24 megahertz automatically, and not 20, and not 0 hertz. And my code. Frequency. Here, the frequency. 24 E6. 24 E6. If you want to see the code, let me switch to camera screen. Wrong one. Full screen. Here. Oh, actually it shows this also. Okay, I didn't know this was allowed. Okay, so here I set the frequency to 26. And now I flash it. This is the serial connection to it. This is using DFU. I wrote my own DFU bootloader. Now it's outputting 24 megahertz when I connect directly. So let's switch back to the bench. Let's connect. So now there's USB. Let's connect and hope that it now works. Please be it this is issue. Okay. This does not work. Is ground connected correctly? Yes. Is USB really the issue? Yeah, it's not able. Oh, maybe the generated clock is not good enough quality. Did I had something more to do? No. I can still check if it reads EEPROM actually, but we know that it was able to read EEPROM even without the oscillator. Do we have to tie down the other input? Don't think so. Let me check if it's still 24 megahertz. Where do we have ground? Ground is here. And let's use the second pin. 24 megahertz. It's on the oscilloscope. So this is this signal. How about Q1? Let's see if it is 24 megahertz too. Oh no, it's not. Okay. Why is it? Did I mix both pins? No. Why isn't it showing a 24 megahertz clock? Let's see. So now there's no clock at all. Okay. Okay, 24 megahertz here. Oh, the complementary output. What is happening? Is the connection somehow wrong? Is this thing too much too loaded? Connection are a bit flaky because it's just Dupont wires. Ah, you don't see anything. So here we have 24 megahertz, but doesn't look too nice. Looks okay. And now we have nothing. Now we have something. Now we have nothing. So there seems to be, is there ground something? And what if I do it on the other output? This is the other output. There's something. There's nothing. So there's clearly some wrong soldering or some wrong connection on these pins. Maybe I shorted it to ground. That could be possible. Let's try the multimeter. And maybe I should let the multimeter in front. Up. Okay, let's have the multimeter in front. Let's see the resistance. So this is disconnected from power. I should also disconnect this one. Everything is disconnected from power. And now if I connect, yeah, there's 10 ohm. Okay, I did short the output. Pads are close to each other. Maybe I should clean the pads. I'll remove the solder from the pads using solder braid, don't know. Up. Let's check the impedance. Let's check the resistance between the two pins. Should be high. Yeah. 5 mega ohm. Okay. So let's solder the pins in. And then check on the pins. The resistance between the two pins. The bottom one is ground, isn't it? Do I see the thermals? Yes, the bottom one is ground and the top one is X1. This is what I've checked this morning before starting the stream. And this way I can better see. Actually, I could do it across the capacitor instead of across the clock. But now it's here. So let's start if this works. So we connect the microcontroller controlling the signal generator. Here we have 24 megahertz. Our ground is not connected. This is why we have such huge peaks. But I don't have enough ground pins. Let's connect this ground. Now, okay, this is 24 megahertz. Now let's connect the USB to this clock. Let's connect it to this clock. If it doesn't work, let's connect it to the other clock. Okay. As soon as I connect... Okay. But it's not the right clock. I want to connect to this clock. Again, it fails. There's kind of an intermittent issue. I don't know what does it. Okay, now we have 24 megahertz. And if I connect the USB, there's no error. Yeah. Okay, there we have it. You see, USB hub found, and this is the right vendor ID. So it clearly is just 20 picofarad. So I didn't know that those 2 picofarad does really do make a difference. In the design, the order I have to make, but for now it works using this, so we can still do the remaining. So we know it's not the USB traces. We had no issue with USB traces. The USB configuration is not good. There's something with the power I need to tweak with the EEPROM, but that's not. It is detected. What we want to do in this stream, because now we fixed this, is to test one of the downstream facing ports. Does it work? And if this works, then in the end we will test if we can control power on the downstream facing ports. This is a feature. So test first the USB data functionality and then the USB power functionalities. Okay. So if I'm not sure, let's try if it tests again. Maybe I was just lucky. No, I wasn't just lucky. It works all the time. Okay, so it's really just the 20 picofarads instead of 18. Didn't know it had to be that precise. Never tested. Can we see in the datasheet? Actually, it would be interesting in the datasheet if it says what the deviation of this picofarad should be. Let me get the datasheets of this thing. USB hub datasheets. Which one is it? This one? Yeah, it's this clock. Let's switch to full screen. This is the crystal I'm using. So load dependent 20, 10, 20. Yeah, specify frequency tolerance. That's the output. Fundamentals. Okay, it's not here. Okay, very good datasheet. Nothing about minimum and maximum. Shunt capacitance. That's not here. Aging. Okay, it's not written. Vibration mode, IT fundamental. I don't know what this is. I think this is maybe how you excite a crystal. But yeah, it doesn't say what the tolerance are. And maybe it's not only due to the clock, it's also how the resonator drives it. I don't know, but it's not written in there. Let's just get 20 picofarads and then it's done. So yeah, we spent 1 day on this issue just because I didn't have a 1 cent part. Very good. But I did learn things, and I think this is why I'm doing it. So this is done. Now we can do the rest. Let's disconnect this, and we will solder the remaining things. Well, we will solder 1 downstream facing port, which will be this one. There are not too many components which need to be soldered because we don't have clock control. So also, yeah. Let's get the datasheet, the schematic, and have a look at the schematic. Hub boards. USB hub schematics. I'll show you the schematic right there. This hub. Here's the schematic, and now we want 1 downstream facing port. It's all of this, but we don't need all of this. The VBus, do we read VBus? I think VBus goes through, oh yeah. VBus, this, so it's enabled by default. Yeah, we need to provide all of these also. On the right. You don't see, okay. It's hard to have multimeter values at the same time as a schematic because the color is not correct. Maybe I just may need to make shadows. For now, let's get not the multimeter values, but this thing. Oh, it's the maximum I can zoom. Okay, this is what we need to solder. The schematic I also have printed out, and now so when I do something, I also print out the schematic, and then I can make notes on the schematic what I need to do and what I cross out. Order 12K. Okay, that was one of the issues, and the other issue is order 20 picofarads. 20 picofarads. And now we get a third sheet, which we will use for the USB downstream facing port. Up. I open the schematic too, so I get the parts. We don't populate everything. This is actually a PMOS. That's why we need drive it power high, active high. Can we cheat? I don't want it to drive the power. I want to provide the power myself. So I just need to pull down the PMOS. This PMOS is controlling the power to the bus. You see VBus 1 here. VBus 1, this is the power that's provided. So, and it goes through a PMOS, and the microcontroller, the USB hub can control using the NMOS, can control the gate of the PMOS to switch it on and off, because the power signal is this one active high. So when this is active, when it is active high on the N-channel MOSFET, it drains this pin, so it pulls this low. So when this is pulled low on the P-channel MOSFET, the MOSFET is activated. So we have the 5 volt going through. So instead of having the default currently on high, which is default off, I could just have this kind of pulling low, if it works. And this way we have the PMOS. Or I just short, yeah, that's another point. I short pin 2 and pin 3 directly on the MOSFET, so we don't have power control at all. It just gets 5 volts. We'll do that. We just short it. We do the power control afterwards. I just want to test if the data of the downstream facing ports work. So let's do that. Yep, this is the board. Here we have all the things for the, and we don't need to solder a lot though. We need the, so the LEDs will be afterwards. No, I can do it now already. Yeah, I can do it now. So let's get some parts. Resistors, transistors, and so on. MOSFETs. I think I can use my assembly board for the resistors. Should be fine enough. We don't need this thing for now. We need one USB port female. We need also the capacitors. Actually, there's another thing which I did not order. But I think I have some. Do I have some? I hope so. Switches. I did not order them. No, and I don't have switches. Something again which is missing from my order. They're huge, and I think I will change switches. These are the switches, so you can actually override if you want the power to be on and off. Actually, you can force off. I don't have the right one, but I have this one. I have no idea why so many parts didn't order. I think there was a page 2, and the page 2 didn't get recognized. Order switch, and for the Next one, I probably may use other switches. This one is huge, and if you see, it will collide with the pin of the power jack because it's so huge. So by hand you can cut them. For assembly, it's not really, you can't do that. So I'll probably get some SMD switch. The problem with SMD switch, I'm always afraid that I break them, but maybe I can still get smaller ones than these ones. But for now, we don't need the switch. We need, these are the outputs. Yeah, this is it 460, which I used? Output capacitor, no, it's 100 microfarads, so this is not the right one. 100 microfarads at 6 volts. I should have a lot more of them. Yeah, these are the ones. 100 microfarad. Okay, I just use 100 microfarad 50 volts for everything. Are these the same parts? I'll probably use all of them. 60, yeah, probably used for all of them because they are common. Do they look the same? Oh no, I didn't. They don't look the same. So it is something else. Something I yet didn't order again. Okay, that's not possible that I make so many mistakes. So many mistakes. Ah no, here they are. Okay, I did all those switches. They are in the box with the other parts which I provided. So here we have the switches, and here we have the output capacitors. That's okay. And these are the farad beads. Yep, this is the USB connector. This is 50 volt 1 micro, a huge one, and these are the SMD clocks. Okay, so I didn't make that many mistakes. We just need one of them. And we need one of these connectors. This wrap. Okay, I just need one. I have no idea how I will keep this thing without falling. I just need to keep it flat. Yeah. Yep. Do we solder it now? We solder probably at the end. Because it will be in the way. Does it actually fit? It's yes, it does fit. So the footprint, I didn't have these ones, so I couldn't test the footprint. The footprint seems nice, although this tab is huge. It could be smaller. This shield tab. So we'll do the through-hole components afterwards. We'll do the SMD components first. This is port number 1. Oh, and I already soldered the TVS diode right there. This one. Which was probably the most important, T105. This is done. So we need some. Oh, there are plenty. I need to order some fuses. I don't have. How do I do? I still have some, but I'm not sure if it will last for all the orders. So 0.5 fuses, 0.5 ohm, and this is actually my enforced power limit. So this chip is capable of doing overcurrent sensing, and there are special chips which are there to measure the current, and if it crosses something, it sends the signals. What I did not know is, will this power the switch off if it detects overcurrent, or will it just report to the to the host that there is an overcurrent issue? I don't know, and I didn't find out the information in there, what it does if it detects overcurrent. And I wanted it to actually I wanted this board to enforce this 500 milliamp current limiting, because it is meant for testing devices the proper way. If anything draws more than 500 milliamps, there is an issue. This is not what the USB hub is not intended to provide power. It's intended to have real USB 2 devices, not charging or something like that. So I wanted it to enforce the 500 milliamp restriction. And this is why, instead of having a current sensing mechanism, I really use fuses. And if the fuse, so if it draws more, then the fuse will trip. This trip will be detected by the microcontroller. You also can see it in the schematic that it can detect it. And this is the OSC, I think, overcurrent sensing, OSC line. And this way we are sure that we still get the information. Yep. But yeah, this way it is enforced. These cables are in the way. So we will see it actually, if it enforces it or not, because I have an LED which indicates the power. So we have 3 LEDs per port. 2 LEDs are there to indicate the speed. So there's a combination of 4 high speed, full speed, low speed, and no speed. With 2 LEDs you can do that. And then I have a third LED. So these are the 3 LEDs. And then I have a third LED which indicates if the power is on or off of the port. And this way we can actually check if it detects overcurrent. Does it switch on, or does it also switch off? Well, we'll see. So we did populate F101. This is done. Now we need to short pin 3 and 4 of Q200. These are these ones. This is probably pin 1, this is 2 and 3, and I need some legs. Let's use the legs of this capacitor to do that. We'll keep the short leg short, and we'll use this leg, which is gone now. Oh no, it's here, so my thing is a tiny bit magnetic. Far too long. Let's get it even more. Let's put some solder on Q102, this one. And we will sheet, and we don't have this. Mouse controlling the outputs. Now, because of the bar, I'm afraid that it will immediately heat up everything. That's okay. Okay, 2 and 3 are bridged. So we've kind of shorted that. We need the resistor for the green LED. It's 1K. Probably have plenty of 1K still. This is 22. This is 1K 5%. Oh, I don't have that many. 1K 5%, and it is 105. Oh, 105 should be somewhere. I expect it to be somewhere around here. Where is our 105? These are the 3 LEDs. Did I put it next to the LED? Where is R105? This is 505, 506. Ah, I'm looking at the wrong thing again. This is why I can't find it. It's on this side. (106). I think 106 is the one for the LED. Yeah, we will also add it to 1 kilo ohm here. So here we have 105. Okay. Here's one LED. Here's the other LED. And this is not a 1K value. I don't know how this landed here. So we still have 1K now at 1%. Now everything I'm buying is, the resistors I'm buying are now always 1%. It doesn't make too much difference in the price between 1 and 5%. For things which are just current limiting and pull-ups and so on, 5% is completely fine. But it keeps my number of reals small if I use 1% all the time, although it is not required to be that precise. Up, so now the 3 LEDs. These are 08, these are 0805 LEDs. I wanted them to be a bit larger, to be a bit, I hope that they will be more luminous. Or at least better visible, because they have a larger phosphorescent dye, but I don't know if this is really the case. And maybe I will switch to smaller LEDs. But for now I use large LEDs. So we need a green one. The green one is for power. The green one is 103. One green LED. Up, one green LED. Did I do it correctly, actually? Normally the 101 and 102 should be next to each other. 101 and 102, okay. And 103, it's this one. Up. We have the indication mark, the cathode indication mark. I hope it is cathode, yeah. Yes, it is. It should always be cathode on LEDs, but you have to check it. And let's solder on it. Normally it should be on because there's always power. How does it do it? Yeah. And it should be relatively faint because I have a 1K resistor. But these LEDs now are so efficient. They have very bright, although there's not a lot of light. There's not a lot of light. So we need red and blue. Red. Red is which one? Red is 102. This is the one on the bottom. Do we have an marking? I think that's the marking. What I also used to do to find out what the marking is also have the parts on a mirror. This way you can actually have a look at the bottom. But now I have this table which is made of caoutchouc, so you can't see the button. So the LED now is not wet soldered. Yeah, beautiful is something else, but that's done. And the last one, blue. And blue, do we check? 101. 101 is blue. That's correct. Blue. Up. This one. On this one, the polarity is different because for easier routing. Yep. Up. I will check the polarity with the multimeter just to be sure. Now that I'm thinking, about it, is it possible? And yeah, it's probably possible in CSS to ask for the fonts to have a border. Yeah, I think in CSS everything is possible. So I'm talking about the values I'm showing, the DMM values I would be showing on the OBS overlay. It's simply a web page actually, which I wrote myself very minimally, but it does work. So we have, this is done, R106, D101, D102 are done. We have R105, which is done, R106, 103, which is done. The OCS, overcurrent sensing, we don't do it for now. We'll do it once we do the power and things like that. That will be the next step. One functionality after another. And then we need C101, which is this one. And the marking. This is weird because on my silk screen, the plus is marked as polarity and minus is not. And on electrolytic caps, you have the other way around, the minus, which is marked. So it's a bit confusing. Once you know about it, that's okay. And I think the IPC guidelines for drawing, or standards, I don't know, for drawing footprints recommends to have the plus of the capacitors marked. Although it maybe not for all type of capacitors, I don't know. Polarized capacitors, that's for sure. Yeah, just be aware of it. I know my footprints because I draw them. Well, I let them generate. But this way, I'm not too much surprised. We wanted to test the LEDs. So LED diode tests. Yes, correct. Yes. Oh, the blue one. So the red one is. Blue one is quite faint, and then the green one also works. Oh, I like how it goes up. Ooh. Zoom a bit more so you can see. Although in HD should be plenty good enough. So I did a mistake. I solved a mistake. I plugged one hole, and this hole plugin will become an issue. So I unsolder I'll unsolder it using my desoldering gun. It might be a bit loud. Okay, now this is done. Yeah, desoldering gun. It's something really. I thought that a desoldering pump is enough, but a desoldering gun really makes the life easier, and it's not too expensive, so I can recommend it. And now the USB port, actually, and afterwards we should be able to test. I need to check in the configuration again if I. Oh, this is okay. I need to check in the configuration, EEPROM configuration, if I actually did enable one of the ports, and if yes, I just want to enable one port, the first one. We'll have a look at it. Up. Again, here we have capacitor for connecting the shield to the ground. There is one on the input port, but I don't know where I read that you can also add on the output ports. But I didn't populate it now. Well, this is not too important. The shield aspect is not too important currently. Okay. This is connected. Up. Okay, this is soldered. Let's have a look at the EEPROM. And in the EEPROM, we'll enable we will enable only one USB port. Full screen. Where did I have it? Let's open yet another window. Oh, there's one here. 5. EEPROM here. 5. These are the EEPROM values, and I need the data sheet. It's this one. 5. That's the data sheet. So no remap, no boost. Okay, these are all the things. EEPROM. I felt here no port disabled. I think I need to enable no bus power disabled. I think I need to disable the all ports except port 1. So port power, current sensing. That's config bytes. We are far below. Non-removable. Port disabled. Port disabled. So it's bit 1. It means 2. Port 1 is this. No, it's the other way around. We have FC. Reserved always 0. Yep, FC. And the same for this one. Oh, actually, power control. Let me check where it is again. Max power for self-powered operation. Oh, that's something else. Power disable. Port disable. Oh, this is something else. Let me read what port disable is. Port disable bus powered. So it doesn't power it. Disables one or more continuous ports. Port is available, port is disabled. During self-powered operation. When remapping mode is disabled. It is. This selects the port which will be permanently disabled and are not available to be enabled and operated by the host. These ports can be disabled. So what is the difference between this and this? If it's bus powered or self powered, we will disable it in both cases. Okay, now I get it. If the hub is bus powered or if the hub is self powered, we will have both configurations, so it will be the same pin. So, and I check raise EEPROM length not 256. This is in case I miss a byte, unless EEPROM length is equal to 256. This is in case I make up too much of a byte or miss a byte. I think there are other self-powered, bus-powered. Yeah, we can write the strings and things afterwards. It's not important for now. So let's generate it. EEPROM. Is it not here? Oh, it is here. Just not. Okay, because I didn't make it as a script. So this is done, and let's get a programmer. Let's reprogram the thing, the EEPROM. Here, overcurrent protection. I also need to power the USB hub because it draws too much. Okay, that was not expected, but that's fine. I need two USB cable, one for the hub and one for the other one. Hub. Although it should hold it on the reset. So on the reset, it shouldn't draw so much power. Up. Up. There is a green LED. I already see it. You don't for now. So let's program it again. Writing code. Okay, validation. Okay. Up. Up. But let's not let the green LED on. But it is very bright. Maybe I should dim it a tiny bit. So if I plug, well, it won't work until I generate the clock. This and this and reset. And let's connect. Now we need to have a look at this one. Now we have a look at the journal control. Bench. So let's reboot this, switch off the oscilloscope, it's too loud, and when I plug in I have one green LED on. Yeah. Oh, there is red, so it did something. Is the USB hub detected? One port detected. At least that's it knows there's only one port, and it says red. The green is far too bright. I need to put some other values. This is 1K, but it is super bright. I need to put at least 2K or something like that. It's illuminating the whole room. We'll test afterwards what kind of value, but it is super bright. At least 2K. But the USB port works, or at least the configuration works that it is only one USB port, And I don't know what it means. So red means full speed, but there's no full speed. I did write it in the comments in my sheet. So red means full speed. There is nothing connected. It should be nothing. This is weird. Maybe it's per default full speed. So let's connect the USB device the right way around. This way. And USB device, one port found. Okay, something happens. Power. Okay, not enough power. I don't know what happens. Let's generate the clock again. There seems to be something wrong. USB disconnect. Why when I wiggle on it, it changes this? See, I just wiggle on the device and it changes the LEDs. Maybe when I wiggle it changes to USB, but this doesn't draw to, does it draw more than 100 milliamp, just a USB stick? Let me test something else which doesn't draw too much. Something like, is this detected when I plug it in? Let me check. This is just a card reader. Okay, the card reader is detected, and it doesn't draw much. So let's test with the card reader. Okay. Disconnected. So there's something going on. As soon as I connected, does the fuse trip? Because it draws more than 500 milliamps. This doesn't draw more than 500 milliamps, never. Maybe. Let me check. No, but no. The capacitor is loaded after the fuse, which is not too much of a good idea, but I don't think that the fuse trips that fast. So I can't measure. I can't measure how much current it draws. What did I do wrong? Did I mix ground and VCC, for example, on the pinout of this connector? That might be the case. So let's get a USB. Let's get the USB connector. Let me check. So if we'll have a look here, we don't see which is which one. Yeah. Multimeter. Yeah, I need to change the color of the multimeter so you can see it. We don't need this for now. Up. Continuity. I know that this pin should be ground. This pin is the last one. So this pin is ground. We can actually measure the voltage, which is easier. But let me check. Okay. The footprint is wrong. How did I fuck up the footprint? So I just need to solder it the other way around. Yes. Yeah, the footprint is wrong. This is ground here, right? No, this is not ground. Sorry, wrong one. Okay. So this, although it is. Let me check. It's this way around. This one is ground. This is ground. Yeah, I think it's the wrong way around. Damn it. The footprint is the wrong way around, but that's not that much of an issue. Let's heat up this. This can be mitigated. I didn't have this connector, so I didn't check the footprint. Let's just measure. Let's get the USB cable. I should have something like this. Maybe I even have something more appropriate for that. Something like this. So breakout board for USB. If we connect it here, if we measure the voltage, this should be V plus. This should be this way, minus 5 volts. Yep, it's the wrong way around. Don't know how I could make this mistake. And it's weird that this connection is flaky. Well, I think this USB cable is very old and not good anymore. This connection is not. Yep. Let's not use this cable. Let's use a cable which is a bit more reliant. This one will go in the not exactly in the trash can, because I think just the connector are wrong, so I can still use the cable for high quality 4-wires, but I can't use it anymore for USB. Really high quality 4-wires, shielded and so on. Let's get another USB cable. But it's not long enough. So let's use an extension. I wanted to connect directly to the, not through a hub, because it is yet another hub, and the hubs don't like to be chained, so I want it to be connected directly to the port of my USB of my laptop. Up. Up. So is my cable flaky or is the connector flaky? No, my cable was flaky. See, I'm moving it, it doesn't do anything here. Dun, dun, dun. Order switch, inverse, type B pin out, type A, inverse, USB A, pin out. So let's disconnect this and this. Let's unsolder the USB ports, and this way I don't have to actually switch. Yeah, this will be actually correct. Okay, so it's maybe a bit loud, sorry for that. Oh, these ones are a bit harder to get. I unsoldered the fuse. I was wondering also why. So when I designed the schematic, in the schematic I wrote that the USB D plus and D minus line are swapped, but only for the downstream port and not the upstream facing port. And I was wondering why, because the connectors are the same, on the same side. And now I know why, because I fucked up the pin out. Although I think I've checked, I have to check again in the data sheet why this could have happened. Okay, let's see if that was enough. One side. No, not this one. Up. Okay. So let's put this again. Right here. Oh, did I break the fuse? I think so. Or maybe just the marking. I don't know, but I don't trust it anymore. The marking is peeling off, and I don't know if this is part of the fuse or not. So let's remove the fuse and put another one. Up. We'll have a look at the datasheet and see why I fucked it up afterwards, just out of curiosity. Tweezer, but that's the right one. I want the other tweezer. Tweezer? 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 Where are my tweezers? Maybe you can see them because you have an overview. I don't see them. Where are my tweezers? Let's use this one if I don't find them. I don't know where I put them. It's weird. I don't know. So let's solder this. Oh, I can also solder the LED for the 202. Perfect. For the green, this is the green. Let's change this LED and make a 2 kilo ohm resistor out of it. With the desoldering gun. It has a huge tip, which is convenient. Up, resistor. I hope this is a 2 kilo ohm. It's written 202, so it must be 2 kilo ohm. 2 kilo ohm. So let's see if 2 kilo ohm is still too bright. I want my tweezers. I can use other ones if I find them. These are not precision tweezers. These are, yeah, these are precision tweezers, but they're not bent. I'm not used to the straight ones. Oh, I should have a second one which is actually bent. Where are my other here tweezers which are bent? But I really wonder where I put my first one. Let me have a look around. Not here. Okay, it was next to my desktop. So 2K. I need to put some fresh solder. Okay. Up. Okay, 2K, and the USB hub. This one, which one is fresh, which one isn't? This one is fresh, I think this one has been soldered, yeah. And because it is a wrong way around, oh, I need to put the ferrite, the fuse. Could this be? Yes. No, it can't. I was thinking about if this could be just going one time to the reflow and one time to the reflow oven, and one time to the wave. If I put all the through-hole components on this side, yes, but all these capacitors, I have to put them on this side if I want this to be a wave thing, and I can't with this thing, this part. No, so I can't. But it's also not meant to be mass-produced. It's meant just for me. This board would need a lot of work to be mass-produced. So, up this, because there's no metal, it doesn't break anything, and this way it is swapped. Come on, shield. Okay, shield 1, shield 2. On my board, only this tab is connected to the shield. There is a huge trace going all around, which is shield. But since these two other tabs are connected on this aluminum shell, it's fine. The impedance is low enough, no matter the frequency. Okay. So let's connect it and let's measure if this is now the right side. Where was my USB thing which I used to measure? So this is the USB host connection. And where is the USB plugged? Ah, here. Which I used to measure. And changing this, will it be hard? Let me check. MOSFETs. Tag. No. Just going this way instead of going here. So no. Doing a relay out for that won't be an issue. So let's just plug USB here. Still, and now we have V minus V plus. That should be 5 volts. Oh, no. Let's go to volts. 5 volts. Yep. Now it is correct. And did I say in the configuration that I swapped it? I don't know. So let's restart our clock. Up. So our clock has 24 megahertz. And yeah, 2K is fine. This LED is not too bright. That's fine. So I will just use 2K. Or 2K2, I don't know. But 2K, this is the green one. D103, 2K. R103, R105. And the other ones are 2K. So let's connect USB. Let's connect this USB first. See if it finds the port. Yes, one port. And now if I connect, no, not this, but directly this, although I could connect it through. Yes, it works. So I said I didn't, no, I did say I swapped it. Let's have a look at the configuration. My configuration. Port non-removable. No, non-removable. Where did I say I swapped the pins? But actually they are not swapped, so let me check in the data sheet. I had too many things in here. Full screen. So let's check why I fucked up the footprints. I'm sure it's just a thing with top or bottom view. Disabled. So somewhere there's a swap pin map, pin compound, dynamic. That's not it. That's not it. Self-powered. That's not it. So it's later on. No non-removable. That's the disable, max power. Manufacturing product string. Here, no strength. That's not what we wanted. No boost. Here, port swap. PRT SVP. And I think I've made this FF. Port swap all ports. Swap all ports but upstream. This is here. Yep. So I need to swap no ports. Let me have a look at the data sheets. Projects, USB hub, and data sheets. Yeah. Data sheets. Which connector is it? It's this one. 5. That's the connector. Why did I fuck it up? Here, I maybe use this one, and this is maybe, it's not written if it's a top or the bottom view. Damn it, I think this is my issue. Let me check. 5. Data sheet, USB hub, board. Let me check at my board layout. Dun, dun, dun. Clipping polygons. This is pin 4. Yeah, so this is the issue. So it's pin 4 because I swapped it, and simply I used this. This says here pin out. Actually, it does. Wow. 1. So it is correct, but they call 1. 1 is not ground like you generally have it on USB. Normally 1 is ground. No, yeah, normally 1 is VBus. Let me check how I did that. CD data project USB hub board, and then library connector. It's USB type A receptacle, and it's 40. This one. Type 1 ES. Generally, okay. Yeah. On USB, 1 is normally VBus and 4 is ground. Here, 1 VBus, 4 is ground. Here they did it the other way around. And it's written nowhere that 1 is pin 1. You just have to know it. So the one who made this design didn't think about how people use it, because I think it's this way. Let me USB, and yeah, universal serial. Oh, why aren't no, the pins are showing. And normally there's a connector somewhere. There's a connector page. I think it's a USB. I have to have a look at the connectors. Serial port, peripherals. Here, USB connector. That's the main article. You see, 1 is VBus and 4 is ground. And in that case, they didn't do it this way. So that's why I'm confused. Although let me... And here, one... No? Yeah. Yeah, they mixed. They mixed 1, 2, 3, 4. Okay, now I know why I did the footprint wrong, because the schematic, the writing is not complete. One is VBus. What? Let me... Did I say something wrong now? Let me check. One should be VBus. And the receptacle... here. One is... You have to flip it. Here, this is standard. I have here. Here we see, and the receptacle. This should be pin number 1. Yeah. This should be pin number 1 in type A. And this should be this one. So this should be pin number 1. So I know why I made the mistake. So my footprints, I need to change. Here. USB pin, row count, pitch, this one. Minus. And this way it should fix the pinout. But we know downstream tracing port works. Now let's solder the part so we can control the power for the downstream facing ports. So here we have that. Okay. So yeah, I use one as VBus, but they don't use one as VBus. This should be VBus, not this one. Yeah, if you look this one, because this is the bar, this is flipped, this should be right there. Okay. Bad data sheet, bad data sheet. But no, not too much of an issue. We found the problem out. Now, where is in the schematic? This can be switched off. We know what this problem was. This is fixed. We will generate the library afterwards. USB hub, I don't require it anymore. Yep. This goes there, and now we do all the power parts. Can I check if it tries to switch it off? This is weird also. If nothing is connected, it's red. There's something wrong. And then if something is connected, the red is off. I may have not used the wrong pin output, because normally, yeah, red, blue. There's Yep. There's something wrong with the EEPROM configuration with how I'm using the LEDs. That's not, normally it's the other way around. And the blue one is not going on or off or something like that. Okay. At 2K, it's still too bright. It's more than 2K, which we need. This was, is it 2K? Yes, it's 2K. this LED is still too bright. 4K7. What I like to reuse a value. What else do I have? 4K7. Let's try that. 4K7. We'll try it on port 2. So we'll leave port 1 as it is, and we will do the power protection on port 2. Just the one next to it. So let's disconnect this power. Let's disconnect the clock generator. Let's switch the camera. Bench. And let's solder all the things. Port 2 is this one. We need a fuse. This. I don't want to test. Do I already test the power output of V-in also? Why do I have so many outputs? Not for now. We'll do it for port 3. For now, we will just test. We'll just test the USB power output and not the 12 volt power output. Okay. Let's go one after another. Where are here? PMOS. And I need my diode book. IC, capacitor, MOSFET diode. Up. TVS, yes, and we need 2 pins, not 4 pins. This is 4 pins, this is 2 pins. This one, we need one of them. Up. I need to order more of these. Order TVS because although maybe I have them here also. TVS, yeah, I do have them here. I have enough of them. I need a power up. I can switch this off. This being the desoldering gun, it's too loud. The fan inside is too loud. Which one is pin 1? On this TVS diode. I don't see it. Here. come on. And I need flux because the solder is not wetting. Okay, and here I've added some solder which I need to remove. Oh. Yeah, desoldering gun doesn't work. Let's use the desoldering gun. 205, we will use 4.7K this time. 4.7K, this one. We already have them because of the EEPROM. And with I2C, I very often use 4.7K. And it's the only time I use 4.7K, I think. So at least we know that the USB hub works. The USB data transfer works. That's a good thing. This is the main purpose of a USB hub. Although probably not for this project. Now we need the other values. What is Q202? So 02 is 02. This is the PMOS, and I think it's this one. Yep. And I need two of them, I think. Yes, I need 1, 2. One is 202. And the first one is 204. I think it should be somewhere around here. Yep, this one. Did I say I didn't want the power output? No. Let's also try it. Let's have the two USB and the power output. .12-volt output. In the 12-volt output, I don't have any overcurrent protection. It's just switch on or switch off. That's all. I need a BSS 128. BSS 128. It's this one. I need one of them. This is to invert. I need two of them. Because I need to invert 2 times. Could I actually use one? No, I can't, because they have different voltages. I need 2 of them. So it's probably this one and this one. Yeah, on the first one, just to invert. On the second one, I need it because the PMOS is pulled up by default to 20 volts, and then the open drain would lower it down. The issue is that the microcontroller doesn't support 20 volts on the input, or 12 volts. That's why I need a MOSFET in between. funny how you can even see the flux inside getting cooled. That's the first one. Let's put the second one. Okay, just lost it. This one. Now all the resistors. Should we do the LEDs? Let's do the resistors. 203. 03 is this one is 100K. That's the one right next to the MOSFET. I think it's the same for the other one. This way it also doesn't pick up too much noise or garbage because 100K is really high. It's a really weak pull-up resistor, and the MOSFETs don't need a lot of current to switch on. Since it's close next to the gate, I think it's fine. $100K, and I think the other one is 204. Yep, right, this one. And 207 is probably, very probably, the 1K protection resistor. Although I'm not sure if you are using, if you're using a transistor to switch to ground a gate, do you still really need an inline resistor, current limiting resistor? And actually, oh, 1K, wow. Is this a design flaw? I think so. Yeah, there's something wrong on there. 107 is also 100K. It should not be 100K. It should be maximum 1K. And actually, I can even remove. No. Okay, it's not a design issue. Okay, now I get it. Let me show you what I mean in the schematic. So in the schematic, write this one. That's what I was wondering. If I'm using a transistor, do I really need a limiting resistor? No, I don't. And I didn't add a limiting resistor here. I just had a pull-up resistor. Here, I've added the limiting resistor. But it's and I was wondering why such a high value? 100K for limiting resistor? That must be a mistake. It should be 1K. But actually, this is not a limiting resistor. Here, we are forming a voltage divider because here we should be able to go up to 40 volts. Or 36 volts, but this MOSFET has a maximum voltage gain source of 20 volts. So this should never be more than 20 volts different than this one. So this should be maximum lowered to 20 volts. And this is what this voltage divider does. There are other ways to do it. I did it using a voltage divider. And it also works with 6 volts because I think this MOSFET needs something like 1.5 volt to activate. So if there's 6 volts here and we put it low, we will have a 3 volt division. So the design is sound. But I can't write everything in the schematic all the time. It's things you just have to... I should put this information though, that this is not for current remitting, but for to protect VGS. Let me write inverse pinout 4K7 auto switch. This is done. Doc, which is R107 documented. Okay. Now this is a 1K. Here's 1K. This is for the red and blue LEDs. Now we just need, no, here there are two resistors. Which one is the 100K? 101, so 201 is 100K and the other one is 1K. So 101 is 1K. So this 1K. And the other one is 100K. 100K. You also recognize it on the board because this is there are thermals on the other pad, meaning it is connected to ground, so it's a pull down resistor. And for N-channel MOSFET you use pull down, so by default it is turned off. Now to the LEDs. We have again these three LEDs of red, green, blue. Yep. Let's start with the blue. Which one is the blue actually? Yeah, I remember. It's the one we didn't see on. I have to check the EEPROM again, why it didn't light up as expected. This is blue. So blue is done. Let me put some tape on this thing, else the LEDs will always come out. Always be a pain in the ass. Blue. I'll do it for the other colors too. Okay, that's done. Now they won't fall off. I just added tape on the sides so they don't fall off when I handle them. It's not how these magazines are meant to be used. Okay, this is the red one, and the red one is this one. Oh, on this one there's no marking on the bottom. On this LED, there's no marking on the bottom. There's only a thing on top. I didn't know that existed. Or at least, well, I didn't try to figure out if it existed or not. I haven't seen one yet. Well, until now. And green, the super bright green. Do we have a marking? Yep. This way around. Up. Up. And I made a mistake. I added some solder in a hole. It's a ground hole. Take longer to desolder. Okay. Now we can put the capacitors. 10 microfarads. We need one of them. And we need one for the larger, for 50 volts. Yeah, 100 for 50 volts. And we need a connector. One of these connectors. So which one is which one? Larger one is C7. Ah, C7 is for this one. Okay. This is the outputs, the high voltage outputs, but it's not the right one. Wait on port 2. This is the right one. Okay, leads off. Second one is this one. So there are lots of capacitors. I hope that these capacitors are able to make it stable. I don't have so many disconnects, voltage issues. Okay. 1, 2, these are off. The USB, but it needs to be soldered the wrong way around, this way, and there's nothing it can touch, so that's fine. And then we need to modify the EEPROM to also enable port 2, or at least to just enable port. Yeah, let's enable also port 2. And also to check why the LEDs are not behaving as we would like to. I don't know. I probably have full speed devices. I don't think I have low speed devices. 1 megabytes per second. I don't think I have some. I have enough low speed full speed devices, which are 11 megabits per second, and then we have high speed devices, which are 480 megabits per second. USB keys and so on. Storage. Very often full speed devices, high speed devices. And things like USB to serial should be a full speed device. We'll try it out and figure it out. And the switch also. So this is where the design, see, if I put this here, this lead stands very high, which is probably in the way of the switch. This is why I need to cut it. And maybe I will just change the switch afterwards so this doesn't go in the way. So we have smaller, some kind of SMD switches where I'm able to put this, because it's very dense. I still need to have some space between this connector, and the next one. Solder wire. Come on, go through it. Now it's the one on the side which doesn't want to go through. I did solder it. Okay, now it's through. Now it's flush. Okay, that's one. We'll try if the switch will. I have to check if the switch switches off just the power output or also USB. I think it also switches off USB. Makes more sense. This takes a bit longer because this is ground, and ground has huge terminal and a huge plane. So let me check the switch. Yeah, the switch enforces on all of them. So let's get one of the switches. I did order them, so they should be. Are they here? Yeah. I use these switches because they're long, and this allows me to have them above the case. But they might be too huge, and I also like the through hole parts. Up. Yeah, but you really have the issue that you're kind of touching the other thing. Not ideal. And it is meant to be this. Okay, so also why I wouldn't be able to do wave soldering. The LEDs, where is the project box? Here. This project box, there is, if you look inside, in this project box, you have these holes for having the PCB flat. This is on the bottom. This is where these things will be. Well, not the connectors anymore. And then you have these connectors which are protruding and the LEDs. So this will be the front plate, and you will have the switches and the LEDs for indicating the status. and then on the side you have the USB connectors, and this huge space from this tab to the top is used for the height of the connectors, the capacitors, and so on. But it might be too high. Let me check if these connectors are too high. Normally I really check that they're not too high, that they're the perfect size. So this is 7 millimeters. This, okay, they're not too high. Here we have 6 millimeters between board and this side, and then on the case we have 7 millimeters between the studs and the bottom. So I did my job correctly there. Finally I did something right. Let's connect this switch, and this switch could handle a lot more current, but we are just switching tiny voltage just to enable and disable and the power. And the switch should work directly also with LED. Yeah. So with USB directly, we could actually test if the switch works. Yeah, don't test if there's a short or not. Let's test it. Oh, now this one tells blue. Weird. Only one port is enabled, and this tells blue, and the green doesn't work. Is something getting warm? The green LED should work. Oh no, for the green LED, no, by default it's now, it only works if USB is on. I want to see how much current it draws, because something is smelling warm. Is something getting warm? No, it's just the impression I have. So let's try. Let's power this. Why isn't the power? Maybe because the port is not enabled, and per default it is put low. Yeah, it's probably because of the EEPROM. So we'll have to change the EEPROM and reprogram it. Let's do that. Let's reprogram the EEPROM. Let me wash my hands and remove the lead from it. Okay, hands washed. Now let's modify the EEPROM so we enable port 2 also. Full screen. EEPROM. It's these values here. So we also enable the second port, it is bit 4. So we have, this is A, I think, FA. Because we don't have bit 4, well, bit 3, which is value 4, and bit 2, which is value 2. So minus 6. 16 minus 6 is 10, which is A. FA. Okay, let me check the LEDs. Which indication? Oh, this is weird. LED mode, speed indication mode. No dynamic. Okay. I think I will. Let me put some space between whenever I have two values. This is two values and this is two values. Let's do it this way. Datasheet. LED functionality. We want the speed mode indication. Red is still the same, right? We are also using red. Yes, we are also using red. Yeah, 4 different colors. Green, red, and off. And I'm using tri-state, no device attached. Yeah, so this should be tri-state when no device is attached. Current limiting resistor hub, and this is on A1. Do I connect on A1? Yes, A1. So that should be fine. So maybe in the EEPROM I did a mistake. EEPROM, where is the LED configuration? Current sensing, I think it's somewhere here. It's this one. Port remap enable, port remap here, LED mode. 01 is speed indication. And we are not using, we are using 01. We are using 11. 11 is USB mode. Okay. 01. Okay. And we also want power control. Max power, power disable, no burst power. Is it written? Where is it that we individual? Here current sense individual port by port, and here individual switching. So we already have the ports switching enabled. Okay, so let's flash the EEPROM. Which one is it? It's this one, this one. Let's make the EEPROM and let's flash it. And to not make mistake, to have it faster, will verification failed. Oh, what is wrong? Yeah, well, I didn't connect it to it. I don't know what it did try. What the hell? I didn't connect the EEPROM. How was it able to write? It's I2C, and I2C, you know if it acts or not. And this one, it didn't act. So, bad programmer. It should have told far early on that there's an issue. Yeah, it shouldn't be able to write code. Here. This way. Ruby EEPROM and this way. So let's try it again. So we have it. Okay. Hup. Disconnect, and now let's connect to USB and find out if first USB works, so if a device is detected, and then if power works. So again, we need to provide the 24 megahertz clock. I need to put some strain relief somehow. So it's 24 megahertz when we plug in USB. Oh, this is weird. Now this light is not bright, although it was very bright before. I don't know what's happening. Now it's very bright. Okay, so we have power on and power off, and it takes time to turn off because we have 100 milliohm. Yeah, we have 100 microfarad capacitor, which is getting discharged. This is also why I wanted it. We have a green LED, and this is discharging the 100 microfarad actually. So this works, and you see 100 microfarad through this LED takes a bit of time to discharge. Now I don't know why. On this one we have the red LED, on this one we have the blue LED, although none of the USB are connected. I don't know what issue is there. So is USB detected? Is it 2-port detected? 1-port detected? No. I did configure 2 ports. It shouldn't be 1 port. Maybe that's why the LED is blue. Why does it tell 1 port? Let's check. Where if we plug this in? Switch the screen. Bench. If we switch this in, it is not detected. So the USB hub has issues. Let's. Okay, you are not detected. Did I configure the bits wrongly? What's happening with this connector? Okay. Did I disable the other one? Now it's tries. Why? Okay, now it's disconnected. Why isn't this one working? But this one is working. EEPROM. What did I do wrong in my EEPROM? FA. Port disable. This is above dynamic. Okay, it's not here. Self, dynamic, power. Here, port disable. Ports 1. If 1, port 2 is disabled, there's no 1. So it should detect the 2 ports. Why doesn't it detect the 2 ports? I don't know. I really don't know why it doesn't detect 2 ports, or why it's not doing 2 ports. Maybe there's another remap. And this LED gets on and off uncontrollably. And here, if nothing is connected, it should not be blue. What is this? Fuck up. If off, you know it, there's nothing connected. USB disconnected. You're telling me USB disconnected. Why don't you turn blue? This is high speed. Let's what? Blue low speed. This is not a low speed device. This is a high speed device. This should be purple. So the blue and the red should be on. And we have full speed. I think. Let me get the serial dongle. I think serial is full speed and not. Well, at least the ones I have are full speed and not high speed. Let me check. Where's the serial? Serial, this one. Vendor, describe it, please. Device, be verbose. This is USB 1.1, so it's a full speed device and not a high speed device. So now if I connect it, it should be red because it's a full speed device. Okay. What the hell? Why is this port switching this LED on? Did I mix up my LED wiring? So, and actually it shouldn't be this way. Oh, there's something I'm not understanding about these LEDs. That is very weird. Let me check the schematic. And let me check the datasheet at the same time with the pin list. So we have LED A721. These are let me check the pin out of this device rather. So LED A1 not. I wrote it that it's 51. It makes sense because it's next to the LED to the here. A1 not 51. That's correct. And then 49 for A2 not. Okay. And what is port swap? I'm not using port swap. So this is correct. 47 is the LED 3. This is right. Then we have 33. It's 4. That's correct. A4N. Then 31, 5, 17, 6, and 15, 7. So my pinout is correct with the LEDs. Let's check the schematic. Huge. Full screen. Let me check. Where's my schematic? The complete schematic. Oh no, actually the complete schematic is on the left. So on the other one, it's correct also. LED 2, LED 3, LED 4, LED 5, LED 6, LED 7. I have no idea what's happening with the LEDs. The pins are correct. The routing is correct. Let's enable all ports. No, I don't want to enable. Why don't you enable? That's a wrong comment. Why don't you enable everything? Here I've changed something. Just use bus powered. Okay. But else the values are the same. And LED indication. Let's check this value again because this LED indication makes me mad. LED usage, LED speed mode indication. That's correct. I2C, EEPROM. Did I do something wrong? LED mode. So it's 1 and 2 it's these 2 bits. These 2 bits here. 0, 1 speed indication mode. That's correct. String enable. String support disabled. Yes, it is disabled. String support enabled to do. No, currently it is disabled actually. We want it to be enabled. Then we don't want part remap. Selects the method to. We don't want port remap standard mode. And then reserved. No, it is correct. This is fine. This is fine. This is fine. I don't know why it behaves so weird. Such a weird way. Let's refresh the EEPROM. I don't know. Yeah, these values I have to change them. Power time English, nothing else is swap all but upstream. Yeah, but it's not remap. That's not no remap status command not used. Bus powered is here one. Current says individual. We have current sense also. We also didn't try if we short what happens. But for now, I want to figure out why the LED don't work. What could be the case? What could be the cause? Is this soldered incorrectly? So let's try it out. We have to go into the diode mode. Diode mode. That's red. That's correct, and that's not going on because it's blue. But maybe 1K. No, 1K is not a lot, but it. Maybe it's not. No, we see that it was able to switch blue on. It did switch blue on here. Here there's also, I missed this this D204. I think it's an RB something diode. This is for the current sensing. Yeah, it allows to do current sensing. NMOS Schottky Xena. I think it's a Schottky diode. I think it's one of these ones. Let's solder. Oh, it's one of the ones which I don't see the marking on. Here. This way. No, it's not soldered on it. And this diode is there so the current sense can be done. In the current sense, normally you have to pull low to indicate that there is overcurrent. And what I do is just I measure the voltage, the output voltage, and well, if it's low, it means that the fuse tripped because it doesn't provide any power, and this means that there's too much current. That's how I use it. Okay, so the power enable, and so we also tested. Well, let's test again this way. I'm sure it does nothing different, but let's still try it out. USB hub detected, one port. There's something wrong with that. So the LED, the blue LED works. I think the brightness is okay with 1K. If we switch on power, it doesn't switch on power. Okay. If it doesn't switch on power, Why doesn't it switch on power? Overcurrent. Oh, so does... Ah, that might be a design issue. So it might really do overcurrent sensing and then shutting down the... I need to put some hot glue here. I'll do that, else it will break. Oh, and it did break. Exactly what I was afraid of. So maybe it does some current sensing. Yep, it broke. Let's fix it and let's put some glue on it, so they don't get destroyed so fast next time. Hot glue gun, hot glue gun, hot glue gun. Up, switch on. This gives me plenty of time to prepare the cable. Up, check. Tack. Tack. Okay. Let's put it flat. So maybe the current sensing does work, but not as I expected it to. And if it does, then my design is flawed. Okay. I'll mark on the thing what means on and what means off. So let's try again. Let's put power on this device so we have a clock. We have a clock. If we switch on, oh no, there's no USB. Okay, this is why. Did I? No, they look okay. Damn it. What is happening now? Reset, so we sure we have a clock. Doesn't seem to be shorted between both of these things. No, it doesn't work. Damn it. Do I have a short? Between these two pins. No, not diode mode, voltage mode. Or ohm. What you wish? 100. That's 100k. Should be 100k. Should it? Let's try again. 100k. Let's disconnect this. Yeah, 1 meg, so that's okay. Connection is fine. Why doesn't USB work again? Up. Plug USB. No. It does not work. Do we have a clock signal? I don't have enough ground pins. Why Where do I have ground? Could I connect it to ground? That's here. Ground. No, we have no clock coming. No clock. Okay, no clock is generated now. What's happening with this chip? So now a clock is generated. I don't know. Ground. I'll leave the oscilloscope on. This way I can really check if clock is there or not. No clock. This is really sensitive. Now there's a clock. I would need some kind of, I don't know how I would test it. I could, if I write the device, I could actually connect the pin back to one of the pins to check if there is actually a signal, to figure out if there is a clock or not. Or maybe it will be a lot more stable once I've soldered it on ground. I soldered it on a board. And now it works. Still just one USB. And now I can't switch on power. Maybe this overvoltage protection, this overcurrent protection, does actually switch off the power. That might be the case. That's easy to test. If I desolder this diode here, I should not do this while it's plugged in. So let's unsolder this diode. Let's not use it anymore. Here we have clock. We have no clock. Still no clock. It's getting generated. No. There's a short somewhere. These boards are not getting power anymore. Oh, here now it is. Okay. This is ground and this is not staying connected. Now there's clock. Yeah, this is really fiddly. As soon as something wrong happens, it stops generating a clock. Now there's a clock. So now, does power work? No. So it's not because of that. I still don't understand why the LEDs behave as they do. Why is there no power? Is the port... No, the port is not detected. The USB hub is not detected correctly. This is getting on my nerves. This connection. I will hot glue these pins on this stupid board. No frequency. Now there is. Now if I connect, now there's a hub. Now this works. Okay. So let me put the glue on it, so everything is stable. And just too much of an error source, this clock. Let's disconnect this. Let's disconnect again. It removed itself. Let's put it flat. And then also I protect my 12 kilo ohm bridge. Add even more glue. To hold it until it is cold, and then I'll do the same thing on this power module. I didn't switch back to the bench. Let's put glue on these things. Same. Oh, this connection is very loose. This DuPont cable is not very good. Let's wait until it cools down. Okay, and let's do the same thing with the ground pin. This should be a lot more stable. Let's try it out. So I'll still use the oscilloscope to figure out if there is an output, but since the pin is now glued, it's not easy to access. This is ground and it's not holding. This is ground. So if I restart, we should have clock output, which we don't. Oh, we do. Okay. So this works, and now if I connect, it finds the USB. Okay, I can work with that. That means switched on, up, switch off the USB. So I will try to cheat with the overcurrent sensor and either connect it to ground or to connect it to VCC. And this way we can actually test what it does, because my design probably did the wrong thing. I need some wires. I'll just use a black wire. Up. I don't need to glue gun anymore. Let's put it where it's not in the way. Actually, I need almost a DuPont cable. Do I have one with a pin? What's this one? Up. Oh, I think it's one of the crappy one which I can't solder on. We'll test. Third hand. Third hand. Up. Up. Yep. Yep, it pulls off it. I can't solder on this one. Let's remove a bit more. Maybe just this part is not good. Let's see if I can solder on this part. Yep, somehow there's some, I don't know what kind of coating it has or what kind of metal it is, but the solder doesn't stick on it. Trash. Up. Let's use another one. We did use a couple of them. From this one, we removed some. Oh, here it is already soldered, so this is fine. And we want, I think it's this pin. Let's disconnect this. I think this pin is the overcurrent sensing. Okay. And now we can touch with ground and so on. Long header. And see what happens. So, if it is floating, so let's start this again. Is USB port connected? No, it's not. So this doesn't work. Still doesn't work. So I really need to all the time. No, we have 24 megahertz there. Okay. USB hub. Okay. So when it is floating, nothing is happening because it is pulled up. And I think you pull it low for detected. So if I connect it to ground, this is ground. It did switch off the power. So the overcurrent sensing does switch off the power. The problem I have now is does it report it actually? Yeah, overcurrent condition. It did report it over USB. And, but how? Okay. So now there's no overcurrent anymore because it is floating. And it is on again. So the overcurrent sensing does disable the power. So maybe I shouldn't use a fuse, but I should use really one of these comparators. Yep. Overcurrent something, switches off. There's still a bit of power, but almost nothing. No overcurrent sensing. The problem is that the way I do it now is that it wouldn't be able to recover. Yeah, it wouldn't be able to recover. I need to put the fuse somewhere else and do the overcurrent sensing somewhere else. Overcurrent sensing. Oh, I need to change the design, that's for sure. I can't do overcurrent sensing correctly. But at least we know that the power control works. because it was able to switch off the power. So that's a good thing. So normally I should be able to remotely. I still don't know why the LEDs work this. What's happening with the LEDs? I don't understand them. Why when I plug here, so something here should be going on, not off, and not here. I don't understand. And this is high speed. If we try with a full speed device, this is full speed. It should do some other LED, but it reacts the same way. So there's something with the LEDs I don't understand. This is, I'm sure this is full speed. Let's double check this is full speed. Up. How do we check it? LS USB minus T. Somewhere we have, I don't know which one it is. LS USB. There is somewhere a CP something. CP, this one. Device 101. And now if we do an LS USB minus T, device 101, 12 megabits. Why do we have the CH? Okay, yeah, 12 megabits. So this is a full speed device, and it doesn't indicate full speed correctly, or I don't understand how the LED works. Makes no difference. Huh? Why do you report an overcurrent? And why are you blinking and you are not switching on and on again? Because now there's no overcurrent and this is floating. So it is pulled high. I have no idea what's happening. Maybe the USB now it just died. Okay, yeah, it's just the clock which died. I don't know why the clock died. Let's put it high somewhere. Where do I have 5 volts? Where do I have 5 volts? Somewhere here. This. I have no idea why. What's happening? I don't know what's happening. Why does this change this LED? Now you provide... I don't get it. So let's try the remote port switching. So this is, yeah, there's an issue with the LEDs and how things work. I don't know what it is. Message. Okay. Remote port switching. I think it's what has changed here? I don't know. Yeah, I'll have to reflash the EEPROM just to be sure it's not a problem with the EEPROM. EEPROM.bin. Yes, that's right. Let's try to control the power of the hub. It still says only one USB. It's hub control. Do I have hub control available? Full screen. Hub CTL? How was it called? Wasn't it hub CTL? It's not here. Didn't I install it? Hub bin. It's not hub CTL. It's something else. It is hub CTL. Let me get a browser. We don't need this one. There are two different ones. Let me get a browser. HubCTL, isn't it the program to switch on and off? UH hub, U micro hub CTL. Okay. Yeah, that's the utility. To control USB power per port on smart. Oh, that's how they're called, smart USB hubs. Oh, everything has to be smart. Sorry for the ranting. I don't like when the USB hub is, when things are smart. I am smart. No, I am not. U hub CTL. I still don't have it installed. U hub CTL. Do you have it? Yeah, do U hub CTL. It's there. So let's install it. No, I don't want it. It looks fine. I didn't see any RM minus RF. UHub CTL. Okay. I want the one with only one power, one port. This one. One port. It's this one. Yeah, I recognize it. That's OpenMoko, and that's the ID we gave. There is power. How did UHub CTL work? Not version. Help. Ports to operate on. Ports. We operate on ports. How do you specify it? 1.3. This way. 131 actually. 131 this way. And action off. Use the limit to limit operation. Changing the port state for multiple hubs is not supported. That's not multiple. How do you specify it? Ports to operate on. Dot one maybe. Dot one. It didn't recognize what I wanted to do. Okay, let's try if it works this way. No. Do you have a port ID with something like this? 1-3. Here's an example. UHub. I know there's another UHub control CTL. No, there is none. Ports. I only want to specify one port. Level, limit hub by location. I don't want to attach to, yeah, I want to operate. Ah, okay. It's port 1 and the hub, the level is 1.3. I think this is I know another tool. I don't know this tool, but no compatible devices detected. No, it should be. But it did actually. It did. No, it did not switch off. The LED is still on. Level 1.3. Isn't that the correct way to do it? I know another tool. I don't know what this tool is. USB hub control. USB hub control tool power. Controlling USB. There's a real stand turntable USB. That's one of them. I know there's another. Oh, I don't. Oh, there's a SysFS also. I didn't know about this SysFS. Oh yeah, there is a auto suspend. Okay. Power control. Okay. I didn't know there's a SysFS for that. I'll try it afterwards. For now, I want USB hub control. Let me switch off the screen so I can have a look where I did it. You can watch the bench while I search for it. Ah, no, it used something else. The other tool, it used the Python interface. Okay, that's not what I wanted. Location. Ah, okay, you can specify by location. Let me switch back. Full screen. You can specify by location. All hub ports, all smart hub. How do you know if it's a smart hub or not? Let's try that. U hub control location 1.3.1 action off. No compatible devices at location. How do you specify at location? This help is not really helping. Is there an example here? Oh, it even lists some. Oh, Amazon Basics. Compatible HUD. Okay, so they are. Very few have actually support per port power switching. Some no longer manufactured or can be hard to find. I have to look. I didn't know this page was end of life. Okay. There are some which support 10 ports Amazon Basics which support switch and USB 3. I have to look for these things. Only work for one charge port. Okay. Or even 7 ports are good enough. Amazon Basics here, Anchor. I'll have to look at this hub. I didn't know this site. So here, how does it work? Compiling. There was another tool I've used. Port 2. That's the permissions. Okay, FAQ. No power switching. Ah, it can figure out gang power switching and USB. Yeah. Well, this is in the USB description. Location. So do I have to specify? I still have to specify the port, I think. No. So the location, that's, what is this? Oh, that's something else. Ah, it was for version 1.3. No compatible devices found at location 1.3. How do the locations work? Location. Yeah, that's the location. B is the bus number and X is the port for all. R port for all ages. So the location is correct. Ah, port. Maybe this. Ah. No compatible devices located. Let me check. Enable connect. Power. What is these things? Ah, low speed. Ah, there you see low speed. Low speed. Okay. High speed. Oh yeah, the mouse low speed. Enable connect. What does these things mean? And here power. I'm sure I can. Not sure I can switch on and off here the powers on these things. No, I can, else it wouldn't be listed. Ah, see, and that's a different, so this D-Link is a different one. It has also a 7 port, which is, well, divided by 2. And this one is located down. But we have this port, USB 2. What is 2.10? USB 2.10? I don't know. What is USB 2.10? I know 1.10, I don't know 10.10. Local to USB specification. But for now, I just want to do this. So if it's listed, it is supported. Maybe I just don't need to provide location. No compatible device detected. 1.3 this way. Oh! This worked. And did it switch off? Yes, it did. You see on the screen it did switch off, but it says that this is port 1. This is not port. Ah, yeah, there's only one port. Switch on. And now it is on. And it let the other LED blink. There's a fuck up with the LEDs and the port mapping. Maybe. Fail to control power. No, switch on power. Off. Fail to control port power. No such device. Send power on request. Okay. That's weird, but it works. I can switch on and off remotely, and this was really my intent. I just need to figure out what's happening with these LEDs. I'll just enable all ports, all 7 ports, and figure out what it if this fixes something. I don't want to touch the setup because it's always a pain to change it, but I need to change the setup. Yeah, I do. I don't want. Okay, too late. It's done. Let's flash it again, and I need to figure out another way because the overcurrent does block. I need to design another way for that. Else the design is correct. So okay, that's connected. That's connected, and now we should be able to flash. EEPROM. Overcurrent protection. I am providing some power here. You shouldn't have an overcurrent protection. But this power is not connected, so I'm not providing power. So overcurrent protection was correct. Okay, so let's try if this works. One port detected. Let's change that. This, let's enable all of them. Just don't care anymore. This way we have no issues, and the LEDs won't work. That's fine. Let's do it this way. Can I flash while it is connected? Does it work? Oh no, it does put on the reset. So I have to disconnect all the time. It doesn't. It would put on the reset if I did connect correctly. So, okay, this is done. 7 ports detected. Well, insufficient power, that's okay. This is because it's not writing, but at least we know we are flashing correctly. We still have this LED issue. What did I design wrong with the LED? One LED is, this LED is, I don't know. Let's have a look at this LED1. LED1, there's nothing else connected. Is there no? There's only 2 LED1s. Yes, that's correct. And the issue is actually LED2. So now, if we check the ports, we have 7 ports. That's correct. And normally it should be port 2 to switch on and off. So let's try with port 2. Oh yes, we're connected through a hub. This is why the location changed. I want to change that. No, let's leave the cables how they are. That's the location. And port, we want to switch port 2. Nope. That's not, this is because it's on, sorry. Off. this. Okay, that works. Port 2 is off. You don't see it, but the LED just switched off. And port 2 on. It's just that I have to read how the LEDs work again. LED usage. Mutually exclusive LED modes. The USB hub provides LED to conform to the USB specification. Functional requirement green amber. The LED speed indication provides a downstream speed connection. I used to provide green LED support. This is the USB mode with 14 wires. We're using this mode. And these are really LEDs. I used to provide connection status as well as port indication. This scheme requires that the LEDs be used in the same package. Well, we have two different packages, but I'm fine with that. And a third color is produced. Yes. Each dual color provides two separate colors. Yes, I'm not using a 2-channel diode. General purpose diode. Why do you put a general purpose diode? So I'm using it this way also, not without this general purpose diode. Let's have a look. For each of this, no, not for each. This circuit should be repeated for each, not this one, because this is on all the logic gates. The green LED will light up. Yes, if this goes low, the green LED lights up. When this goes high, the red LED lights up and not the green one. That's okay. And when it's gray wave, we have both colors. And yep, that's it. Pulse at 1 kilohertz, tri-state, no devices attached, other hubs is in suspend, LEDs are off. That's not the case currently. The LED is on. You are not in we have the blue LED. The blue LED is this one, so you are pulling low. And that's all. I'm not doing... The only thing I don't have is this general purpose diode. This is maybe to drop the voltage, but who cares? It's just for... Probably it's just to drop the voltage, but we have the current limiting resistor, so this should also be sufficient to drop the voltage if it's high or low. Why did you add a diode here? And why do you behave such a weird in such a weird way? So the current sensing, I need to fix that. I need to change the thing, because it does switch off. It's not just an indication. It does actually switch off the power. So it again, if I put to ground, ground. Yes, current sensing does switch it off. So I need to change that. I don't know if I don't have space for a chip, additional chip. I need to find something else. USB failed to suspend. Yes, don't care. Let's connect again. 7. USB hub detected. Now if I plug this in And actually, we will see if it's a full speed or low speed device. LS USB. Come on. Minus T. Now somewhere we have our hub with only one device, with 7 ports with only one device. It's not this one. Hub 7 ports. Here, CP101. 12 meg, so it is low speed, and you're not driving the low speed correctly. So low speed is purple, blue. It should be at 0 volts. The blue should be on. Well, the blue is always on, but now it just switches off the red LED. Yes, now the red LED is on. I don't know why. Ah, wait. This is why. This is why there's a general purpose LED. Because no, we have 2 LEDs here. If we have 3.3 volts, none should be on when it's on a stray state. Maybe this is why the general purpose LED is. I'll try it out. Let's unplug this. I will just provide 3.3 volts between the LEDs and see what's the state. Up. So here we have the device. Let's go to the bench. Bench. I need some wires with 3.3 volts. 1 and 2. That's correct. Voltage 3.3 volts. Okay. Between maybe if I do this, I power the hub. Damn it. It's between this one and this one. Yeah, the red goes on. Why doesn't it go on this one actually? Between this one, the red also goes on. Okay, so the general purpose diode is just to drop the voltage. So we don't have the red always on. Maybe that was the issue. So that's a design flaw. So yeah, I should have used the design as they did it. Do I have general purpose diodes? I think I'm only using MOSFETs, Schottky diodes, but could use a Schottky diode that probably also works. Do I want to try to remod? And why isn't the blue LED going on? Oh, and here I did a design mistake. On this port, I moved the LED. I shouldn't move the LED. Oh, although it depends which one it is. Yeah, but it's the wrong one. I should move this LED. Okay, I see a design mistake here. That I have to fix. Yet another one. Oh, this project will never be finished. Ah, this is ground, sorry. So the red LED goes on, although the other thing is in tri-state. No, it's not in tri-state. No, it's not in tri-state. I'm testing some completely things wrong. I just provide power here. Obviously the red LED goes on. That's the purpose. but I can't provide 3 volts to can I to just the 2 LEDs. Yeah, I can. It's no, I can't because it will switch on everything else. It's between what is ground? This is ground. No, this is ground. This is 3 volts. No, I don't have it here. I need to test with 2 LEDs. This is ground. This is 3 volts. Yeah, it switches everything on. I need to solder 2 LEDs back to back and see if 3 volts light it on. Because this is the case when it's in tri-state, but normally it's the blue LED is 1.8 and the green 1.5, so it maybe does. How do I do it? Do I get a breadboard? Do I just solder back to back? What can I use for trying out what happens with 2 LEDs? Yeah, I need a small board. Prototype board up. We can actually measure the voltages and add them. So we are using red and blue, right? Red. Red LED. Do you see the measurements? Yes, it's here. And actually the DPS, yeah, this broke. So we have this LED which switches on at, that's the wrong way around, this way, 1.7. And now if we use the blue LED, if it's at least 1.8, it should not be a problem because it should not be able to switch on. And blue requires higher voltages, like something like 1.8. Yeah, even my multimeter can't show it. So the blue LED is on. The other way around. This way around. You see the blue LED is on and the multimeter doesn't see the voltage. And I think the maximum voltage of the blue LED is, I don't know what it is, but it is above 1.8. So even if I put the 2 in chain, 3.3 volts should not enable them, but we'll try it out. So let's get a board to play with. Up this way, and we'll solder the LEDs on this board. Where are my fine tweezers? Yeah. Up. I think in the schematic the general purpose diode is really to drop the voltage. So even if you use low voltage diodes, low voltage LED, it doesn't matter. Okay, let's try out. Let's limit to you don't see the power supply. No, you do. You see, I think this power supply is dead. Okay, now it's on. Yeah, I have to test the timeout for the power supplies and check if it's still on. So I want to limit myself to 10 milliamps. 10 milliamps. It is on. Where are the two pins? 1 and 2. And now let's try this out. 1 this way. No, this way? Okay. 10 milliamps. Red works. Now let's connect the other LED. Is this soldered on? I have some doubts. Let's try it out. 1, 2, this way. Yeah, blue. Blue is on also. So now if I do this way, we're at 3.3 volts. So if it's in tri-state, solder from this hole. It doesn't work with this tool. Normally you have to do it from the other side. Okay, did work. So plus, minus here, nothing works. If I do it here, it's red. Okay, nothing works until I connect these two pins together. Let's have some jumper cable and connect these two pins and see if it's on. So this is a tri-state mode. Yeah. Up. Now, if I connect this to this and switch on, the blue is on. No, it's not. I just made a see, nothing is on. Yep. So in tri-state, really nothing should be on, and only when you pull one of the things. So my design is not really wrong. Although I don't have the diode because of the blue LED, we are far above the 3.3 volts. So here nothing can happen. Only if I, yeah, this way or this way. But if I leave it this way, nothing. So okay, my design is not, it's not that wrong. Yep, no LED goes on. The voltage is just too high between the two of them with the two in series. Okay, so that's not the problem is not my at least not this part of my design. So why do the LEDs behave incorrectly? Does it have to do with remap? Current limiting resist. Yeah, for the overprotection, it wasn't written that it switches off. Maybe it's a USB standard. Overcurrent sense. Overcurrent sensing. So here recover. USB integrity. That's not here. Configure delay time for filtering overcurrent sense input. Okay. Overcurrent sense detection. Yes. Overcurrent sense. What is what is these? I think I need to check these. These are the pin description. There's also there's something with gang here. Port swap. And the LEDs. Maybe I didn't understand last time what the port swap was. I wrote it here. Swap all but stream. That's not what I mean. PRT swap. This thing. Does it have to do with LED indication? If this strap is enabled by package and configuration setting, LED indication, LED 1. What? Here, internal default state, strap option, share enabled. I don't think, I think I use 2i2c EEPROM supported. Strap options are disabled. I think this is my configuration. Check the schematic. So we have self 2, which is grounded. That's okay. Then we have cell 1, which is 1, and cell 0, which is actually 1 because it is pulled up. This pin is shared with I2C clock, and it is 1. So we're in this tape, so we're not using any strap options. So sorry, yep, full screen. So that's not it. So yeah, overcurrent sensing, we were there. Overcurrent here, and then I just see if this strap is enabled. Strap is not enabled. Port polarity normal, LED is active. LED is swapped. Port polarity is swapped, LED is active low. But they all have the same thing, and we have 2 different colors. So that's not swap. Okay. Overcurrent sense, overcurrent strap option. We don't have strap option. And we don't use any of these LEDs. We leave them floating. Overcurrent sense here. Input for overcurrent sense contains internal power up to 5.5 volts. Yeah. And ganged overcurrent sensing. No. We have everything in the EEPROM option. Port strapping. Current sense. Here, current sense. Selects current sensing port bases. Overcurrent not supported. We do overcurrent sensing timer. That's when to block. Default configuration option, internal register, USB recovery. See, there's nothing which tells you that it is actually switching on off the power when it is sensing overcurrent. It's not written in there. OCS. Overcurrent sense again. Overcurrent sense negative. Yeah. OCN. Yeah, it's not written in the datasheet, so I couldn't know. But now I know that it's when it does detect overcurrent, it switches off the port. So I need to find a way to. And the problem here is that if it switches off the port, I cannot recover. Another way to be able to recover from it. Okay, then. So now the LEDs. I need to figure out why the LEDs are so fucked up. This is in the EEPROM. EEPROM. Nothing to do. HS high speed disable. Did we disable high speed? I don't think we did. GIG, okay, yeah, bus. Self, okay, we don't care because we have dynamic. Okay. Yeah, for now we tell it is bus powered. Bus powered, this is the first bits. And now, yeah, the first bit tells we are bus powered and we have no dynamic. Okay. Then reserved, HS disable. We had 0, that's okay. Empty, we have 1 LT per port. Actually, this is what we want, which is right here, I think. So, yeah, bit 4. That's bit 4, empty enabled. 1 per, yep. 1 per port. Then we have EUP. I don't know what EUP, end of packet. End of packet is normal, we keep it normal. Current sense, gang sensing, we have 0, 1, individual port by port, that's okay. And then power, gang switch, individual, we have individual, that's okay. Dynamic, we don't use it. Overcurrent timer, when to trigger the current when it is detected. That we can increase a tiny bit to, yeah, for now, yeah, let's leave it to 0 because we don't have any other mechanism. Okay, so that's all fine. Compound, we don't have compound. Reserved. Port read map, we have no port. Yeah, this is the third register. This is this one with the LED mode. No port remap, that's 0. That's this 0, 1, 2, 3, that's 0. Standard mode, LED mode. Maybe maybe it's not 0, 1. That's bit indication mode, but it's something else. Maybe it's bit swapped. It should be 1, 0. Do not attend an LED mode that requires LED that are not available in the specific package being used in the implementation. I think you mean the dual package. Let's try with 1, 0. I mean, there are only 4 possibilities. Maybe one of them will work. This needs power. So 0, 0, it's probably not it, no matter the thing. So let's flash it. Okay, it is flashed. I need power for the clock. Okay, the clock, no, not the FU mode. Okay, the clock is there. So now if I connect the USB hub, USB is connected, USB hub. And the LED is still the same. So it doesn't make it, well, let me plug something in to figure out if it does something. No. And why did the power get disabled? Okay, now the USB hub has issues. No, this should be switched off. Let's reset this. Power is enabled. Behaves as it did before. Do I have the right data sheet? 2018. Okay, it's another too old data sheet. No, it's not 1, 0. Let's try 1, 1. Oops. Okay, this we don't need anymore. same behavior. Okay, I'm doing something wrong with, maybe it's not the right byte I'm writing. Maybe I'm not writing configuration byte 3. Let's check it out. Puts EEPROM, sorry, EEPROM, and we will actually put the binary value and the hex value. I think it's this way, and it's register 0x8. So how it should be is, what is this LED thing again? Yeah, it should be 0, 1. Yep. 0, 1. Yep. So if we print the value, you should complain. Yeah, it's okay. That's the right mode. USB speed indicator. I'll have to look at the new data sheet. Let's see if something else. So non-removable, port disable. Port disable self. So we don't disable any ports currently, right? Port disable, we don't disable any ports. Since we're not using this anymore, we'll leave it up this way. Yeah, the max power, that's something we know we did wrong. Max current, this is something, yeah, this is something we know we did wrong. Power on time, the length takes from the time hosting share power in sequence on a port until power is stable on that board. Yeah, don't know. Language, these are strings, manufacturer string, product string, service string, boost, we don't do any boost. Boost, we don't. No boost, everything is at 0. Port swap, that we do. Port swap. Reserve. What? Oh, the reserved bay, I did put F9 in here in reserved. Maybe I should put 0, 0, and it's a kind of hidden functionality. That could be. It is reserved. So it's after the boost, right? We have register F7, F8, no F9. Yep, this is F9. If that's really it? No, that can't be. Failed. What did you fail? You should reset. You should enforce reset low, and you do. Let's try again. Writing failed again. This connection is okay. This connection is also okay. Plug, replug. Now it's okay. So now let's connect again. I have to remove this. Oh wow, that's it. Now let me show you. I'll switch the camera. Does this one show what I want? Can this one switch? The USB, come on, the HDMI switch doesn't switch. I don't want to restart OBS. Well, now I have to restart OBS because of the USB. Let me restart OBS. USB just got... Okay, and we are back. OBS restarted. Actually, I have to figure out if my HDMI grabber are not drawing more than 500 milliamps. I can cheat by providing... Yeah, we'll do it afterwards, by providing external power to it. So you see now the LEDs now light correctly. Both of them are green and they are not red LED. And this is because I wrote a value in a reserved register. I didn't write 0. I wrote something else. I think this will work fine now. For example, yes. This is red is low speed. Was it this way? Check the schematic, but it seems to be correct this way. So I entered this red full speed. Exactly, that's the full speed, and this is then it draws more. Oh. Why don't you recover? Because USB just died. Up. USB on, and we have the red and blue LEDs on, and red and blue means high speed, purple, yeah, high speed. So it works. So really, I wrote in an undefined register. Let me check EEPROM. I wrote something in this, which one? In this register, F9 here. I wrote something in this reserved register, and because of that the LED were behaving something in a different way. So it's kind of a debug mode probably which they use. There might be some communication or not, but at least now it works. Yeah, and purple works, so everything works. The overcurrent sensing needs to be fixed, but else my USB works. And I'm sure that the high power also is switched on and off. This is just a MOSFET. There's nothing wrong in there. So there's still a lot of kind of enough fixes on this board to make. But yep, that's it for today. I need to design more. I don't know if you want to watch the design I do or not, but the stream is ended for today. Our USB works, power control works, overcurrent detection does not work. We have to fix that. Okay, until next time, maybe when I designed the next board and ordered them. I don't know when. Till then, enjoy.